Second talk this morning in track one. We are now listening to Tiberiu and Andrei about hunting for LoLs, and we are looking forward to the talk.
Okay. So, hello everybody. Thank you very much for joining this talk. My name is Andrei Cotaie, and together with my colleague Tiberiu Boros, we're going to have a short discussion regarding a project we recently open sourced and that we're actually really fond of. So, a supervised machine learning living of the land classifier. A couple of words about us. We are the security intelligence team. We are a part of Adobe Security Coordination Center. So basically the ACC handles monitoring, alerting, and incident response. In other words, it handles reactive security. Now, the purpose of the security intelligence team is to do data science research in the security field. So we also mostly focus on reactive security, and that basically means identifying threats that cannot be detected via conventional ways, via static rules, more or less. Now, in other words, we use the logs and the security data we collect from Adobe assets, and we try to find anomalies and, of course, bad stuff. We really like sharing our work outside of Adobe, and we have quite a couple of open source projects, presentation, and blogs, and we're actually going to touch bases on some of those later in this talk. Cool. So what is living off the land? Now, easily put, living off the land means doing your job with what you have at your disposal. But let's be honest, those are not the 14th centuries anymore, right? Or the Middle Ages. And the truth is what we have at our disposal is more than enough. Living off the land is not a brand new concept. Living off the land attacks, persistence, lateral movement, all kinds of techniques have been recorded and reported for a while, since the beginning of the century at least. All the big kids are doing it, APT groups are doing it, researchers are doing it, pentesters are doing it, and purple teams, and so on. Now, what's really interesting about the living of the land attacks is the fact that the footprint of the attack itself is really reduced, right? And that's because you don't have new binaries there. You try to blend in, and well, you already have everything you need there at your disposal. And the truth is, between us security professionals, like if you have Bash, Python, PowerShell, Certutil, curl, Wiget, and whatsoever, like what more do you actually need to do your job there? Plus, in my recent investigation, I really noticed that Netcat became like a default administrative tool on most of the Linux installs I have. So admins are really fond of Netcat. In other words, living off the land refers to attack scenarios where multiple segments of the attack itself, multiple components, stages, are being delivered with whatever you have already on the compromise box, on the box you compromised. So no external, malicious, specially crafted tools or malware for that matter. Okay. And again, the whole magic is the fact that what you need, it's already there. And some people did an awesome job documenting this, right? Like there are the two living of the land URLs there, which have a lot of examples regarding binaries and how they can be abused to do all sorts of stuff, which maybe they weren't intended to do, right? So, for example, you're on a compromised box and you want to download something, well, go to the link and you're going to find the best examples you want for Certificate or other BusyBugs or other tools you have there, right? You want to abuse a legit binary to execute something, well, again, go to the link, see what you have on the box, see what's present in there, see how to use it. You want to escape a text editor, well, that's awesome. Again, you're going to have plenty of examples there, really, really well documented. Okay. Now, the honest truth is that things aren't always that straightforward. Even if you are on a compromised box, maybe things you're going to find there are not going to satisfy your needs. But it's a great starting point, right? And again, you have a lot of power on the box itself. So a clear advantage of using on-prem stuff, like scripting your way in if you want, is the fact that you actually blend in. You are one with the environment. You are an administrator there, and you can behave like one. So maybe you're a good administrator and you also want to patch the box so nobody else compromises the box you're already on. And if I recall, there were some stories a couple of years ago where different APT groups, different attacker groups were actually fighting for compromised resources over the internet and kicking out on each other. So those things actually can happen. Anyway, let's get a little bit serious here. So what we actually want to talk today. Me, as a security expert, historically, I handled quite a couple of incidents and security investigations. And almost every time I learned something new. That's the fun part. Something that actually evaded the security measures in place there, right? Something which maybe on its own would have evaded my security mindset. Also, if I'm speaking about Adobe, we work with petabytes of data, right? So it's definitely a lot more than a couple of dozen of humans are actually able to parse and understand by far. So how can we make sure that what I'm able to detect I'm able to detect and protect against things I have no idea of, right? Like things that might bypass my security stack or my security mindset. And the honest answer is I cannot, but I can give it my best shot. And I can always think outside of the box. And this is actually what this project is about, thinking outside of the box. Now, we took thousands of examples of malicious commands from threat intel reports, incidents, open source, GitHub scenarios, living off the land pages, and so on. We did some magic around them, and then we actually built a classifier whose entire purpose is to tell me if a particular piece of string looks like a potential threat and why. And why? That's really important. Why? Now, as you can see really fast, the tool is actually pretty easy to use. You just paste in the command and it's going to generate some tags. And well, the classifier is going to classify the data, right? It's going to give me a result. Now, regarding the target environment, the Living of the Lamp project we open source comes with two models, a Linux one and a Windows one. Currently, the performance of the Windows one don't make it qualified for production-ready environments, and we estimate we're actually going to have a stable model somewhere in the next release by the end of this year. Now, the Linux one is really similar to the one we're already using in our infrastructure, targeting Adobe data, and it's really, really high accuracy so far. So, with that in mind, let's talk really fast about the magic behind the project. Cool. As I previously said, well, metadata, and for me metadata actually mean tags, so it's actually all about the tags. The tags are the magic, right? So the training data is critical, as for any machine learning project, but the magic is actually in the tags. And my classifier is as good as my tags are, and of course as my data set is. Now Tiberiu is going to discuss more about the data set and the model a couple of slides later, and he's going to give you the magic from that component. So tags. What kind of tags do I actually generate? Anything that crosses my mind, but let's not speak about the Living of the Land, let's speak about myself. So I am a male in my 30s. I wear glasses. I'm starting to get a little bald. So those are all kind of tags that describe me at my current state, right? So the same I want to say about my commands, right? So I care about like what was the binary executed there, what was the path from where it was executed. If I saw that in the past, I care if it communicates, with who it communicates, how it communicates. I care about keywords. I really care about those little dashes and parameters that appear there in my command. And I especially care about patterns. And good patterns are actually a game changer in this project. Cool. So what do I mean by binary tags? What I want to do, I want to go really fast through the tagging and try to highlight you that the fact that tags we're adding there, they are a security subject matter expert kind of approach, like we're embedding our knowledge in the project itself. So the concept for binary tags, it's pretty simple. I'm checking if a particular binary executable, however, its name is actually part of the command itself. So we basically made a list of some of the most interesting binaries from an operational security perspective. And every time we analyze the command, we check if any of those words actually present the command. Straightforward, right? If they are, we add the tag to that event, like command and the command itself. Historically, when we started to build this project, those were the first feature we actually built our classifier upon. So on the slide, you actually have a really simple example of a standard Python interactive shell. What we do, we break it into words, and then I'm checking if a command, Python 3 in this case, is part of the list that I generated there. Now the code behind it's a little different, but the idea is exactly the same. Now for keywords, the same for keywords. Keywords basically represents a list of interesting keywords or parameters we identified during our research phase. So for everything we thought it might have a security implication, we created a list and we do exactly the same check. Like in the slide, you can see really fast I'm using PTI to check if PTI is present there. Now, all the static information that we're presenting here, the feature extraction component, the tagging mechanism, every security magic expert piece is actually present in a constants.py file. So there is actually half of the magic of the project, right? So basically, again, this is the subject matter expert, security subject matter expert content of this project. So you can modify the constants.py file at any time, add stuff, repair stuff, remove whatever you want, and it's going to reflect automatically really fast in the generated tags. But it's going to be ignored by the machine learning model, or it might have a negative impact because the machine learning model wasn't trained on that data so far. Cool. So next, paths. Paths, it's exactly the same thing. We made a list of interesting paths for different Linux processes, binaries, interesting directories, and we check if those paths are actually present in the command itself. So this is useful because it can highlight different activities, like interesting activities, sensitive files, binaries running from different wrong locations. And again, all that information is present in the constants file, right? And all those are actually used to generate tags. But if you want the model to have an impact, you need to retrain the model. So the development of this project was some sort of a modular approach. We initially started with interesting binaries and keywords. We built a classifier, we tested the classifier, and we were disappointed. So next we added interesting paths. And we did the same again. We built a classifier, we tested the classifier, was better, but still disappointing. So then we added networking information. So basically what networking does is checking if there is an IP information inside of the command itself. IP information, that's really important. And I'm just saying, well, is it public, localhost, private, and so on. Now, you're not always going to have the IP information in the command, but most of the logging utilities tool that we have out there is definitely going to present the IP information somewhere in the event itself, right? So what we do for our case, we basically take that information and append it to the command itself. So we always deliver that information when it is present. Now, what we're trying to do. So imagine you have two SSH reverse tunnels in your infrastructure, and one is going towards a public IP, and one is going towards a private IP. So which one will actually check first? Which one do you think it might have a more security implication than the other? Which more likely is actually an operational stuff, right? So the same security mindset we try to embed in the project itself. So networking had a significant impact in the accuracy of the classifier, but it was still good enough. And my favorite part, regex. And this was actually the game changer in the overall accuracy of the project. So after tagging the data with commands, keywords, paths, network information, we still didn't reach production-ready accuracy. So the question was, what can we do better? Like, what other features can we extract from our data in order to increase the accuracy and reduce the false positive? And the simple answer was actually regex. Now, historically, I've been working on content creation myself, like rules creation, notables, and so on. And I know that regex can generate two problems. It can be too strict, and that means ignoring interesting events, or it can be too broad. And again, that means creating a large number of false positives. So what we did, well, we actually went with the second approach, like broad regexes, but many of them, hundreds of them to be more precise. So the idea was to catch as many features as possible, as PTI, spawn, netcat, man map, netcat flags, and net flags, combination of those flags, and things like that, right? Bash parameters and so on. In the end, take all the data we generated, put them through a classifier, and let the machine learning, the classifier, decide what's malicious or not. So even if we actually have a lot of what might be low confidence tags because of the regex. And again, we have many of them. The regex added a lot of context, and the machine learning started to behave better and better as we added more and more context. Now, from a technical perspective, we encountered one major problem. The feature extraction component became really slow, so it took a lot of time. So we actually switched from regex to regex 2, the implementation from Google, and we switched from a series execution, like one regex at a time, to parallel execution, where we actually added groups and made OR statements between them and tested everything at once. And that actually reduced the complexity of the process with almost 8 times. So it actually became faster than it was initially. Now, the same goes for regex. All information present it's present in the constant.py file, and anyone can edit regex, because we might have regexes there which are not at their best. They can need some fine tuning. But in order for them to provide context to the model, you need to retrain the model. So you might just need this project for the tag instance, right? Like you might just want the tags there for you to create a data set, analysis, RBA implementation, also on, or you want to do your own classifier, which is perfectly honest there. Now, any modification you do the constant.py file to the regexes, you can modify, delete, or add them. You're going to see them directly in your results. But in order for those tags to actually have an impact to the model, you need to retrain the model, because new tags are going to be ignored by the model, and regexes that actually have been modified and they're computed alpha different might have a different impact on the model itself than you actually would want it to. So we actually had one major update yesterday on the regex side of the house, and we're actually going to push the latest version of the model today. Okay, now I'm going to pass it to Tiberiu to show you the magic behind the data and the model.
So good morning, everybody. I'm going to start by saying that the most important thing about our machine learning approach is that we are using supervised algorithms. And these algorithms are data-driven, which means that in turn, they require labeled training data. Now, the problem is that a large-scale data set for living off the land is really hard to find. We struggled with that, and we actually ended up creating our data set almost from scratch. Now, living off the land is open source, and we do provide a system and pre-trained models, but we are unable to share our data set with you. If you want to create your own custom model, that's not a problem, because you can actually build the model yourself. It's pretty easy. You can follow the same steps that we did, and it just requires some, minor work and effort, but it's going to be worth it, since you will be building a model that, it's custom made for your own infrastructure, and it's going to reflect on the false positive rate and also the true positive rate. So how we constructed our data set, we started by collecting 1,600 examples of malicious command lines from the open data sources that Andrei mentioned earlier in the presentation. And we added to this data set a number of 7.9 million examples of benign command lines that were extracted from our own infrastructure using an EDR solution over several weeks. Now, the data set is really skewed. The ratio between malicious and benign commands is 0.02%, but that's actually okay. We didn't want to get to build a balanced data set, since the F score on the false positive rate was not going to reflect the actual truth about how well the classifier works. So instead of having a really paranoid classifier that labels everything as being malicious and creates a lot of false positives, we have something. So we aim to build a classifier that is really reliable, and whenever it says that something might be malicious, it's worth investigating. So just to get a better view on how this works, if you'd be collecting like 100,000 command lines per hour from your infrastructure and your false positive rate would be 1%, you might say that that's not really too high. But imagine that you'd be creating 1,000 false positives per hour, and somebody would have to be looking into this data and to see if it's actually malicious or not. Now we have a pretty stable model. We only generate like 5 or 6 examples per day, some of them being from our internal pen test, so they are not false positives. And the other commands, I mean, you can quickly browse through them, see if something is wrong or not, and you can, label them accordingly. Now, we use the labeling scheme that Andrei presented earlier on the entire data set. We got a number of 7.5 million total tags on all the data in our data set. Now you can imagine the number of tags is smaller than the number of examples. And this is because, I mean, some of the examples are not really interested and they are not handled by the, the tagging scheme, and they will literally get no labels at all. Some of them are going to receive multiple labels. You saw in the examples that we can assign 3, 4, 5, 6, 7 labels per single example. The number of unique tags in the dataset is 500. So given this ratio, I mean, those who are familiar with machine learning, I mean, I'm going to realize that we are not dealing with data sparsity at all. And we are unlikely to overfeed the model on the training data and generalize poorly on previously unseen data. Actually, if we move to the next slide, we are going to show how we tested the classifier. So we took the labels, the labels from the data was assigned earlier, and we trained 3 classifiers on the data set. And we validated them using something called k-fold validation. For those who are not familiar with k-fold validation, the idea is really simple. So you need to split your data set into k folds. Those folds have to maintain the same data distribution as the original data set. So basically you would want that the ratio between malicious and good examples would be the same 0.02. Obviously you cannot get that good of a split of the data set, but the closer you are to this distribution, the better the results will be, and actually the more reliable the F score you are reporting will be on the classifiers. So in our after you do this split, you are going to train the classifier k times, and you are going to use k-1 folds for training, and the other fold that is kept aside, you are going to use it for testing. In our case, we set k to 5, so we did 5-fold validation, and the table shows the results obtained for a random forest, an SVM, and the logistic regression, the mean F score, the standard deviation, and also the training time. Now, there are 2 very important aspects to mention about those classifiers. So the random forest is the only classifier that was able to work with sparse input features, which meant that we actually didn't have to convert, the input feature space into a dense matrix. And this greatly reduced the memory requirements for the classifier to train. And the results, the 3.5-hour training time for the SVM classifier is actually reported on scikit-learn, which had something called an Intel patch, which enabled the classifier to train on multiple threads at the same time. Without this patch, we were virtually unable to train the classifier and report the results. There's one more thing on the next slide about our classifiers. So we do rely on the classifier to say if an example is good or bad. But we felt that if something is already in the training data set, and we know that it is bad, it has been labeled bad, we don't want the classifier to miss. This could happen because, the classifiers are not perfect. We might not have assigned enough tags for those examples. Something might have gone wrong, but we don't want to miss them. So we created a new tag, which is called looks like known living of the land, looks like known LOL. And we assign this tag based on the similarity of a new example compared to malicious examples in our data set. And we do a fuzzy comparison. That means, we want to be, not to be sensitive to changes in the command line itself. So we might be having a netcat with an IP in our data set. But when it's run on our infrastructure, it has a different IP than that inside the data set. Now we can do that using some heuristics, remove numbers, remove special characters, and you can solve that you can solve this in using those heuristics. But we felt better that we can do some fuzzy comparison between the strings, and say how well they resemble each other. Two main options to do this. Levenstein distance is the obvious choice. However, it has a high complexity and it's going to slow down the project very much. So instead, we use something which is called blue scoring. Blue scoring is something that has been previously used in machine translation. Whenever a software would translate a sentence, you'd have a set of gold standard sentences, and you'd want to measure how good this translation is against those gold standards. Now, the blue score is going to return 0 if two sentences or two command lines, in our case, have nothing in common, and it's going to return 1 if those are almost or are identical. So, I mean, after playing with the examples in our data set and the command lines that we are testing on, we said that if something has a blue score above 7.7 with anything that was labeled malicious in our data set, we are going to add this looks like non-lol tag. And also this tag is going to override the decision of the classifier if that command line has been labeled benign by the classifier. It's going to change the decision and is going to mark it as bad. On the next slide, we'll talk about how you can install and use LoL. So installation is pretty easy. There's the simplest, easiest method would be to use the predefined pip package. It comes with the entire API and also pre-trained models. So you just do a pip install lolc, and it's going to install it on your virtual environment or on your local Python installation. The second option is actually to use the GitHub repository. You just need to clone it, create a virtual environment if you want, activate it and install the requirements. And there you go, you have a working installation of Living of the Land. The second option, although it is a little bit harder, you can actually use this if you want to build your own custom classifier and build a new model for your own infrastructure. Now, to use it, it's fairly simple. You can do it via command line. Andrei already had a movie regarding that. Or you can use it via API. So the first step is just to import the lolc, which is the main object in the API, on the platform type. The second step is to create a new instance, and where we can choose between Linux and Windows as the platform type it's supposed to run on. Now, we do provide both models, Windows and Linux, but the Windows model is still really unstable and is not production ready. However, the Linux model is pretty nice, and you can experiment with it yourself. Next step is to get your data. You can actually run the Living of the Land classifier on a single command line or on a batch of command lines. In the background is going to do some parallel threading, and is going to, the batch version is going to work faster if you have lots of command lines. And either way is going to return to a tuple. The first one is the classification. I would say binary, but that's not the word to describe it, because it actually have 3 states. I'm going to talk about this later in the demo. So it returns the classification and the tags that the Living of the Land classifier used to establish if a command line is good or bad, is malicious or not. I guess the best thing to do right now is actually do screen sharing. Andrei, can you stop sharing a little? Okay, thank you. And I'm going to share my Chrome. Okay, I hope everybody can see my screen. So what I did, really simple. I created a virtual environment and just installed the Jupyter notebook in it. And I'm going to go for the pip package installation. I'm going to run this cell over here. It installed really fast on my machine because everything was already cached. I'm going to create a new instance, and then I'm going to apply the Living of the Land classifier on all those commands here, one by one, because I want to be able to quickly look through the data. Now, you can see that it is trying to describe the data. So it's an SSH. It saw the loopback IP, the public IP, the command line SSH. It's looking for keywords, and it matches a pattern in the regex space. The same happened to this command over here. So it saw that it's a sudo, it contains which, keyword install, SSHD, which is probably is the combination between the starting SSH and -d. And it also added a looks like non-living of the land command because it resembled something in our data set. It did the same for a couple of examples. This one is pretty interesting. So as I said, the decision is either bad or good, or there is a special case for neutral. Now, neutral means that the classifier was unable to assign enough tags. The minimum number of tags that it's going to make a decision upon is 3. So if it doesn't assign at least 3 tags, it's not going to make a decision, good or bad. And this is normal for command lines that are really short, like the apt-get install Python. This is a normal command. It's not really interesting, so we didn't add any tags for it. But if you have a really long string, many characters, and you are not assigning enough labels, it means that, or it might indicate that you are dealing with something that is obfuscated, and you might want to look into that. Some of the commands have the looks like non-lol, and this has overwritten the decision of the classifier. Others are simply going to be marked as bad because of the behavior itself, like this one over here. So it's a PHP, it's opening a socket, in running an SH, and so on, which is actually really good. Now, as Andrei said, this is the constants file. You can add interesting binaries here, interesting Linux paths, keywords on the regular expression. Now, this looks really bad. You cannot edit this variable here. I'm going to get back to this one. Below, those are the keywords for Windows, the same paths and keywords and the regular expressions. And for the regular expression, you can see that it's a really, really, really long string with parallel regular expressions here, right? We do have a tool. You just need to add your regular expressions one by line. The regular expression, how the tag should look like, and it's going to do the magic. It's going to group them together, and it's going to run regex in parallel, so it doesn't slow down the execution of the project. I'm going to stop sharing right now and ask Andrei to take over the presentation again. And we will be moving on to how you can use living of the land. So, 2 major options. The first one is to use it as a standalone tool. The second one is to use it into a project which is called OSS. Now, while living off the land actually treats commands individually, and it doesn't take context into account, OSS, which is a previously open source project by our team, it stands for One-Stop Anomaly Shop. And what it does, it actually takes a lot of context into account. It tries to model anomalies based on all the data it can get from EDR solutions. So it's going to use not just the command line, it's going to use the username, the process name, the environment variables, and whatever else you want to use inside it. So it's going to bring in context. It's not going to treat the command lines, individually. And the architecture of OSS, it's on the next slide. So OSS, it's a configurable pipeline. And it takes a input data source. It can be a CSV, it can be a JSON, it can be Elasticsearch or Splunk or whatever solution for log managing you are using. And it's going to it's going to use the same strategy as the living of the land classifier. It's going to try to assign labels to instances of the raw data that it sees. And we have predefined recipes for numerical fields. They are going to be based on the mean and standard deviation. So if you have high CPU usage, it's going to create a label. It's going to say extremely high CPU usage. If the name of the field is CPU usage, memory usage the same, number of access requests per second, and so on. Next, it has a predefined recipe for multinomial fields. These are text fields that don't take all the possible values that a string can take. So the string can be virtually unlimited as values combinations go, but multinomial fields mean that if you see you have 1,000 entries in your data set, and you look for a specific field, the values in the specific field, you're just going to get 1% unique values. And some examples of multinomial fields can be the username. In a an environment, this is finite. Actually, you're not going to have an unlimited number of users. It can be the process name. It can be environment paths and variables and so on. It also has another recipe for text fields. Those are free form. They can be command lines or text, comments, anything. And it's going to use natural language processing here. It's going to build a language model for those strings. And again, it's going to measure the perplexity of new values. And based on that perplexity, again, it's going to assign tags. And it can do combinations between any types of fields. So it can combine numerical with multinomial with the living of the land classifier, and so on. Doesn't matter. And it also uses the living of the land classifier. And when you are going to apply it to a field, it should be a command line, because otherwise it doesn't make sense to apply it on normal text. It's going to take also the tag as the binary decision that LOL has assigned, but also all the other tags that it's basing its decision upon. And again, after it goes and it labels all the data set, it's going to do anomaly detection. And we have unsupervised anomaly detection, where you can choose between an autoencoder, local outlier factor, statistical engram, frequent item set mining. And you also have a supervised module, which lets you access actually any classifier that is inside scikit-learn. But you are going to actually provide it with training data, which means that you need to add a field to your training data, a label that is going to say this example is good, this example is bad. So you can train the classifier to predict that the value for that field for previously unseen data. I guess that's it about OSS. I think we can move on to the questions.
Okay, questions from the audience? And I have one from the chat. What are the scores normalized for dataset bias, and can we see a confusion matrix?
Yes, we can see a confusion matrix. 1 second. So unfortunately,
from yesterday.
Is this in your SourceForge project? So you could simply point the question there.
So we didn't report the accuracy on the open source project.
Okay.
I can show you a confusion matrix. It's in my console right now.
Okay, while you are searching another question, if you want to evade your system, spreading commands over time, would this be caught by the OSAS or? Yes, so OSAS does basically gather the whole stream and analyze it.
Yes, so I mean, they are kind of complementary projects. So if you're going to try to evade the living of the land classifier, you're probably going to do that by obfuscating or encoding the command lines. So I mean, when you do that, it's going to create a high entropy for text fields, and that high entropy is going to reflect in the anomaly scoring. So OSAS is going to highlight those examples that contain really weird-looking command lines. And it's going to order them, and they will be on top, so you'll be able to spot them easily.
Okay.
We also actually have a module in OSAS which does detection of obfuscated commands, so that's also going to provide value there.
Okay, great. Anything from the audience? Then thanks a lot. We are doing a coffee break now and meet 20 minutes later. Thanks a lot. Maybe you can still put up the confusion matrix if you
yes, I found it. If
can,
you want, I can
but
share my screen.
Okay, let me stop.
Okay. This is a little bit weird, so.
It's okay, Tiberiu.
Yes. So this is the confusion matrix for a fold on the model we trained yesterday.
Okay, thanks. Maybe you should put up more examples on the GitHub, on the project page too, so people can look at that.
Yes, we will. Well, thanks.
So
Thanks.
guys,
Thanks a lot.
we have actually one favor to ask you. Tibi, can you give me back the screen?
Yes.
Give me 1 minute. 1 minute. That's it. Okay. So our ask is actually do please visit our GitHub page and give the project a try. If you have issues or commands which are not available, please give them to us so we can update the model for everybody. And also please give us a star.
Thank you. And I also suggest the more in-depth questions from the chat to be directed there and discussed on your GitHub project. Thank you.
Thank you.
Goodbye.